on to day 2, and today's theme is sort of, making nano. How are we going to create the objects that we've been talking about since yesterday? So, and I wanted to go over sort of what we talked about yesterday through our gots and needs that you guys submitted yesterday. And so what I really liked, and these are just a few pull quotes, but nanoscience is used in many different industries like medicine and manufacturing. I think that was a really good point. Also, feel free to put some information in the chat. I think Jenny and Kritika are talking. I know it's kind of hard when it comes to the video. Sometimes there's like a sound lag or whatever. And, I know some people prefer not to use their video, which is totally fine, but I do ask that you participate in any way that you can. So please feel free to use the chat and again, the reaction buttons and things like that. Sorry, not to digress, but another thing is that the greater surface area makes nanoparticles more effective particles and reactions, right? So that was really good with the Alka-Seltzer demonstration we had. And again, the surface area to volume ratio functionality. So, by shrinking things down, you can put way more things into your phones or like your little handheld devices. And the self-assembly, when matter is able to arrange themselves in a specific arrangement. I thought that was a nice way of putting it. And then so on the other side, on the right side, is sort of what we are needing as a group. So more examples of how this can look in biology, physics, chemistry, physical sciences, and maybe an example lesson plan, which we will all get to later today. And then Jenny and Kritika are going to present on Thursday to sort of talk a little bit more about what their lesson plans, their units actually look like. And then how does nano correlate with arrangements? So they see the connection between size, reaction rate, and delivery, but sort of unclear on configuration, placement, and arrangement. So hopefully today we'll sort of answer that with the making nano parts. All right. Does anyone have any other comments on this or wanted to add anything? Okay, we're going to keep moving. So again, the big ideas that we learned yesterday are what is nanotechnology in a sort of general sense, right? And nanotechnology is really driven by small parts being put together into larger parts, which is the bottom-up fabrication or the top-down fabrication, which is the sort of big thing getting cut down to smaller pieces. It has a lot of different unique properties, right? We can use them for a lot of different applications with a wide set of fields, and self-assembling is one of the unique techniques that we sort of delved into. Surface area was another one that we delved into. And I think the biggest takeaway is that it's very, very small, right? That was sort of the big part where we were looking at when we started, right? To really get a framework going. All right. Does anyone have anything to add to this, sort of the big ideas or anything else like that? Should we just jump into it? Okay. All right. We'll jump into it. So yesterday you sort of had homework, which you either did today or maybe this morning, or yesterday or this morning. So we have our groups. Oh my goodness. And what you'll do is, let me stop sharing my screen for a minute so I can share my other screen. So you're going to go into your breakout rooms, and then you're going to take a look at the discussion diamond, which I think a lot of people are already on the screen for. But we're going to just try this. Usually we do this with a large piece of paper, but obviously we can't do that. So we're going to try it this way. So each group, which I will read off again, or I'll put them in the breakout rooms, and one person should grab this and then share it amongst their group. Okay. and then you can type and write into it. I think that's the best way. You'll write your name, so my name, and then you'll write sort of your key takeaways from your issue. Does that make sense? And then after you've completed your individual quadrant, you'll actually sort of come together and decide on what the big idea is from all your 4 different um, issues. Some of them, I think you may only have partners or to a consensus of, looking at each other's little quadrants, what sort of consensus you can come up to. Okay, does that make sense? So I'm going to put you into the breakout rooms. If you have any questions, feel free to ping me. I'll put you in the rooms for about 10 minutes in total, but I try to spend 5 minutes individually on writing your section and then another 5 minutes doing a discussion, okay? And I'll be popping in and out to do that. So so I'll give you 10 minutes and then, all right, okay, and go. I'm gonna pause.
It's time cut out, but
Mm-hmm.
oh. And well, I'm going to share my article. So it's the issue on the environment. I found it really interesting, like how technology is being developed to like measure pollutants in air. Hold on. Oh, okay. Like it's being measured, like being used to measure like pollutants in the air, such as like sand or like dust or asbestos, or like other chemicals, and like how they're like utilizing like basically like these sensors that are the size of like computer chips to like monitor like these airborne nanochemicals, basically.
Yeah, but thank you. Yeah, that's really cool. Yeah, there's a lot of environmental things that are going on when it comes to using nanoparticles for sensors or even for cleanup. So thank you. Anybody else want to share anything?
Okay, I can share
Sure.
articles for about 5 senses. I thought in the beginning maybe it was just for kids, but as soon as I started reading, I said, "Oh, that's interesting." So I kept reading and reading. So it talked about the 5 senses, and one thing they mentioned that the nose, the smell, is least studied. It's less understood. I mean, how the particles, when we smell something, how these molecules binds to receptors, and the receptors send the signals to the brain, and that's why we smell things. And some smell we think is good, and some we don't think is that pleasant. So interesting. And then when the next page was about a lady who did her PhD in physics, and in the interview was, okay, she said that she was probably felt that she was the only female student in physics, but since she liked science, she said, well, I went ahead, I didn't care, and then she got her PhD. When I further went there, so they talk about the bionic nose. Okay, because now as we learn more about how this natural organs work, so we can make a copy of that. So they're trying to make a bionic nose detect different kind of smell. So then they're also looking at the skunk. They look at the skunk and for its defense, how it releases ethyl mercaptan. That's the chemical it releases in the air, and a lot of animals or even humans, we don't like them and you want to stay away from it. So how these chemicals bind to the receptors, so interesting. And I'm not sure there's not enough time to explain the whole thing. Then the last page that was interesting to me was the sucrose, the natural sugar and the artificial sugar. That was interesting because I know people that are trying to lose weight, they want to use artificial sugar. So I looked at those molecules and I noticed that the sucrose has 23 atoms in each molecule. And aspartame, that's what we call this artificial sweetener, it has 21. And so then it prompted me to go and do some research. So I went and spent several hours to look at the adverse effect of this aspartame. I said, okay, if you're going to use this artificial sugar, is that's going to affect us or not? So it's actually, we call them artificial, but it's actually not artificial. It's made of something natural. So then I looked at it and it said it doesn't have an effect. Now that I said, okay, me personally, one day I was drinking coffee and I would put a spoon of sugar and two. So one day I was telling myself, I said, why am I adding sugar to that? Am I drinking this for sweetness or I'm drinking coffee for caffeine? So 4 or 5 years ago, I stopped it. And I stopped it like first few times it looked, weird, but then it's been 4 or 5 years. I don't use at all, and my brain doesn't want sugar anymore. So I got used to it. So then I thinking, well, this is a good article, and especially for people that like diabetic and they don't want to get too much sugar because they are not producing enough insulin. So that's a good article for even adults, I think. For kids too. If we explain that to the kids now, that's a good idea. So that's
Yeah.
all about it. Yes, interesting. I enjoyed it.
Oh, very good. Thank you. Yeah. Does anyone else want to go? Did anyone also do the biology one or the five senses? So we will talk about biomimicry a lot too today. But yeah, anyone else want to share? We have a few more minutes. Oh, Samantha, I see you raise your hand.
I have a question. My article is really easy. If you guys just take like 5 to 10 minutes, you can read it. I started typing and I noticed I was saying too much. Like I filled up my box and I'm barely on the third page. So I think it's a great way for me to teach kids like, hey, you got to be more succinct with your note-taking skills. I'm this old and I'm still saying too much. So I try to tell myself, okay, what is it that's most important? Those 4 titles that is on the cover, like what one sentence can you get out of it? And my, I guess my titles kind of just teach you right there that the movement of molecules, you just need to know all atoms, all molecules are moving at a very, very fast rate. And that scientists are trying to learn about these molecules, but you got to freeze them to see it. And that's absolute zero. You have to get it at absolute zero, something that we cannot do humanly possible. So we have computers to do that stuff for us. And that's what my whole thing was. I thought it just touched on simulations. The scientist was a simulation person. There was an expert who does simulations, but it was all about manipulating the simulations so that we can see how the molecules work. And then someone who took out the molecules and made the letters IBM. So that was like, really cool.
Oh yeah, we'll talk about that.
So that was that person.
Today. Yeah, great. Okay.
But I wanted to ask, I really raised my hand to ask, are we going to be able to see everybody's discussion diamond? Because we're not done yet. Our group isn't done.
Okay, if you want, maybe why don't we have it sort of be due at the end of lunch, so you'll have some time to finalize it, and then I can share it. I'll make that right after, or I'll try to do it during our guest speaker who's patiently waiting for us. But I just wanted to. So I will send out a message regarding that. So if you can finish it, if you're able to do it and finish it, then you could submit it to me. I'll make us an assignment for after lunch. Is that okay with everyone? Okay, I see some nods. Okay, awesome. So I just want to wrap up the discussion diamond. I know that this is kind of a hard format to do. And again, I think if we given enough time, maybe if we assign this as homework, it would be better because then everyone would have more time to actually write the information down and then actually regroup maybe in the morning. But the whole point of this thing, which I really love, is that you're able to have each person, have a voice and talk in a small group, and then eventually share that voice out to a wider audience, right? That's sort of the whole point of this. So you can have multiple layers of discussions about similar things, but then also have that wider discussion. So you're able to have people who may not want to talk as much, or maybe may not want to talk in large groups or large group settings, to have some accountability and ability to just have room to talk. So that's what I really like about the whole process of this discussion diamond, and then obviously breaking it up. So with the Nanoses, I really love them. They're wonderful. They're actually produced by Cornell University. One of my colleagues there has produced them. They sometimes it's like a year goes by or 2 years goes by before an issue comes out, but they've been doing it for quite a long time, and they've done a great job. And so I think they're really fun, engaging articles that make things really interesting. And you can get them. I only was able to send a few to you, but you're able to actually download them all online for free. So I'll send the link out to that as well when I create my assignment, okay?